solved in the last class. Huh? We have completed that. And what about anomalous behavior of water? We have completed that also. Anomalous किया उसके बाद ही आया हमें Hobbes पे. So we have done Hobbes experiment as well as the consequences of anomalous behavior of water. So is this unit completed?
Yes.
Okay.
So can you explain again the Hobbes experiment?
Hobbes. All right. So for that, just make this. Everybody is clear with anomalous expansion of water.
Yes.
So what is that? What is anomalous expansion? देखो, expansion क्या होता है? Whenever any substance is heated, it expands. ठीक है? When it is cooled, it contracts. But water के case में, from 0 to 4 degrees Celsius, उल्टा होता है. When water is heated from 0 to 4 degrees, instead of expanding, it contracts. ठीक है? At 0 degree, water will be in the form of ice. So when ice melts, its volume reduces. Okay, so that's one. When it is cooled from 4 to 0 degrees, contract नहीं होता, तब वो expand होता. Okay? So because of that, what happens? The density of water is maximum at 4 degrees. ये चीज दिमाग में रखो. So due to anomalous expansion, density of water is maximum at 4 degrees Celsius. So keep this in mind. Okay. So we Hobbes experiment is basically verification of this. Okay. So Hobbes experiment में हम क्या करते हैं? Hobbes experiment क्या करता है Hobbes experiment? It verifies yes anomalous expansion of water. मतलब क्या verify करता है? It verifies that the temperature of water body, right, will never go below 4 degrees Celsius. Okay, in the inside of any water body, right? It will be freezing only at the surface, not inside. Inside temperature will always be at least 4 degrees Celsius. देखो कैसे हो? So this is some cylindrical vessel, right? Now 2 holes have been made here. Okay, it is filled with water everywhere. And earlier we made 2 holes and fixed 2 thermometers. This is thermometer 1 and okay. Below we have thermometer 2. Why do we need thermometer to measure temperature? The thermometer. Now let's say it's a winter season and the outside temperature is, let's say, 12 or 10 degrees Celsius. Okay? So right now full water temperature is 10 degrees Celsius. Now what is done is we are fixing a tray in the middle. What are we doing? We are fixing a tray in the middle. Okay? So tray has been fixed in the middle. Now what is done is we have filled the tray with ice. Okay? What have we done? We have filled it with ice. Got it? So before filling the tray with ice, what was temperature shown here by T1? 10 degrees Celsius. T2 would also show 10 degrees Celsius, right? Before ice was filled in the tray. Now what is being done is, when ice is filled here, what happens to the water in this region? So its temperature starts decreasing, right? So when the temperature reduces, what happens to this water? It will contract, means it will become more dense. So density means it will become heavy. So this water will fall down. The water in the middle region, the cold water in the middle region will begin to sink, right? Lowering the temperature of lower thermometer, right? So, and what happens to the upper water? Upper water was at higher temperature. It is lighter, so it remains at the top. So only this water, which is in contact with the ice tray, will become dense because it is contracting now. From 10 till 4 degrees Celsius, it is contracting. Okay. So what happens? A convection, the cold water which is in touch with the tray will come down, and this warm water will go up. It will become cold, and this is called convection. What is convection? The cold water will sink because it becomes heavy, and the water at higher temperature is light, so it will go up, replace it, and this cycle will continue. This is called convection current. Okay, convection current will settle, right? Water current, convection current, till it reaches 4 degrees Celsius. So the lower temperature will show, lower thermometer will show 4 degrees Celsius, while the upper one will continue to show 10 degrees Celsius, right? Now, so ice is like what, at 0 degrees Celsius? So this water in the middle region is further lowered to till 4 degrees Celsius. Everything is become 4, not it is 4. Now the water in middle region is, let us say, becoming 3 degrees Celsius. Okay. So what happens now? If it is 3 degrees Celsius, now its density decreases because maximum density of water was at 4 degrees Celsius. Yes. So maximum density of water was at 4 degrees Celsius, right? So all that high density water will be in the lower portion. Now, the moment this temperature reaches 3 degrees Celsius, then what happens? It becomes lighter, isn't it? Density of 4 ki maximum hai. So 3 degree per density reduces. Anything which is lighter will go up. So this water now begins to flow upwards. So the water which is heavier will come down. You understand? So now everything, so till 0 degree, this water, this temperature will reduce to 0 degree. So it happens in 2 steps. First, the whole water in the bottom, right, in the bottom portion will reach 4 degrees Celsius. Okay, and this thermometer will continue to show 10 degrees Celsius only, right? But the moment this temperature reduces less than 4 degrees Celsius, then convection current sets in the upper portion, right? Now everything becomes 0 degrees Celsius. So it verifies anomalous behavior because pond mein yahi hota hai. The upper surface freezes, right? Whereas the lower body temperature remains at 4 degrees Celsius. So in laboratory also we can verify this. Clear? Okay. So if you read the book, so if you draw the graph of both the thermometer, right? So let us say this was 10 degrees Celsius. Okay. This is point B. Okay. So during A and B, the temperature of the upper thermometer remains same. But after B, it reaches 0 degrees Celsius. Right? Here, what happens? This is 0. In case of the second thermometer, how the graph will be? This is T1, right? Graph of T1. T1, right? This is graph of T2. So where is the reading shown? T1 is here actually. This time. This time. This is the temperature. In this case, while it remains constant at 10 degrees Celsius, this reaches at 4 degrees. Okay, so this is A and B. And after B, it remains constant. Does not go below 4 degrees. Which one? The lower thermometer. That's what it says. Whereas, while in this time, when it goes from 10 to 4 degrees Celsius, right? This remains constant. And then after that, it reduces till 0 degrees Celsius. But this remains constant. Is it understood? Okay. So, any more questions on hopes? Experiment? Hopes. Experiment. Okay. I had explained the consequences of anomalous, the bursting of crop stem and the water pipe. So with this unit is over. The next unit is about energy. So this chapter had two parts, right? Heat and energy. The heat part is over. Okay, so the heat part is over. Rest 3 chapter is all about energy. Okay. So what is the next part? So as we all know that we need energy to do. Yes, energy is needed to do work. Right? We can just survive. If we survive only, then we can do work. Right? So energy is required to survive. Right? So what is the primary source of energy? Primary source of energy is sun. Right? Source of energy for us is sun. You all agree?
Yes.
Okay. So basically, on Earth, we have living beings and non-living beings, right? So living beings are also called as. So everybody requires energy, living beings or non-living. I think you must have learned about it in biology or EVS. Living beings are also called as biotic. Okay, biotic entities. Right? And non-living beings are biotic. So called as biotic. Right. So living beings and non-living beings together form, what do they form? Ecosystem. Okay. So we have to understand the energy flow in the ecosystem. So let us understand the energy flow. To the ecosystem. Right? Let us do the ecosystem via simple food chain. So this will give us the idea how the energy flows from sun to last entity in the ecosystem. So let us understand that. So starting with sun. What is sun? The primary source of energy. Now, the energy from sun reaches us in the form of radiation, solar radiation. Right? Of all the energy radiated by sun, right? 60 to 67% or 70% is absorbed by atmosphere. Okay. So out of the balance that reaches Earth, right? Almost 10% is absorbed by the water bodies. So 70% of the Earth is consisting of water bodies, right? And very few part of energy is received by plants, right? So what are these plants? So plants receive sun's energy, a very small portion of it. And then what they do is they convert that energy into chemical energy through a process called photosynthesis. Okay? So plants through a process called photosynthesis convert the solar radiation into the form of organic compounds. Right. So organic compounds are like carbon and hydrocarbon. So it is like chemical energy. So energy is received by plant and it is converted into from solar energy to chemical energy. Right? So it has undergone transformation. Right? So what are plants doing? Are they eating anybody else? No. So they are preparing their own food. So they are called therefore primary producers. Plants are called primary producers. Okay, they are primary producers of right. So they are first in the food chain. And these plants are eaten by krill. Krill is a aquatic species. Aquatic species. ठीक है, वो कुछ ऐसा prawn जैसा दिखता है. Okay. So it consumes plant, right? So therefore, this is the primary consumer. Right? So primary consumer. So how it receives energy? By eating plants. So this is also called as herbivore. Okay. Does it receive full energy from plant? Some of so all this krill, when they eat only some percentage of plant, and some plants will just get decayed. They will die without being eaten, right? Plus, whatever portion of the plant it has eaten will also there will be waste produced by it. Okay, so that energy is also gone out. So what you see is during energy transformation, the efficiency is not 100%. A lot of energy is wasted. Okay? Full solar radiation is not converted into chemical energy. A lot of it is already wasted. Then in the next stage, when the energy flows from plant to krill, again full energy from plant is not gone here. Plant consume some own, keep some own some energy for itself because it undergoes what? Respiration, right? It's like if I'm earning say 1,000 rupees, I will not spend all 1,000 rupees on my family members. I also need food. I need clothes for myself. So let's say 200 I'm spending on myself, 800 for others. So whenever energy is received by anybody, it is never passed 100% to the next entity. Okay, some of it is used by itself. Okay. So now, next to krill is eaten by small fish. Right? So this is now called secondary consumption. Okay, and it will be carnivore. Because now it is eating krill, a living thing. The plant is a living. It is carnivore. Okay. So only a part of energy from krill will reach here. Some of it will be wasted. Right. The small fish is eaten by a large fish or a big fish. So this is a tertiary. Okay. So it is a tertiary and it is also carnivore. Then the large fish is used by consumed by humans. Those who eat non-veg, right? So humans are the last consumer. So they are the big boss on planet Earth, right? Right? Unless he is very unfortunate and landed up into an island where everybody is a cannibal. So otherwise, they are the last consumer. So what did we learn in this energy flow process? So humans also will get part of energy from the large fish, rest will be wasted. So not all the fish on the planet has been eaten by humans. Some fishes will die being uneaten, natural death. Right? So they are wasted. The energy got wasted with them. It never reached the next entity in the food chain. Right? So what have we learned? During transformation of energy from one entity to another, some energy is wasted, right? And then the energy flow is in one direction. Energy flows linearly. That is in one direction. What it means is the energy which comes from sun never reaches back to sun. It is always one way. But energy flows linearly. That is in one direction. So it comes from sun, but never goes back to sun. It's one way. Understood how energy flow works in the ecosystem? The same process, what I have explained here, has been explained with two flow charts. So you can take a look at that. It explains the same thing. 6.7 and 6.8. 6.6 is what I have shown here. So look at 6.7. They have only put a number to how much calories of energy is received by sun. Okay. So sun's energy is received by plants, which are producers. So plants are the only producers of energy on this planet. Okay. How much energy was received? 20,810 calorie, let us say. This is the amount of energy received by plant. Then plant keeps some energy for itself, right? So the energy wasted in respiration means, why are we saying it is wasted? Because it is not being passed on to the next entity in the chain. So who is the next entity? The primary consumer. He receives only 3,368 out of 20,810. So how the energy of the plant wasted? 11,977 in respiration, right? And decay. Some of it is decay. Okay? You understand? The balance energy in blue is after respiration. Then the plants also undergo decay. Means they are not consumed by the primary consumer. So that is decay. So the balance, this minus decay, reaches the primary consumer. Okay. So they have just shown a number. So you can just read through it once. And the same thing is shown in the next diagram. Okay. Explain the same thing. Okay. So just spend some time with the diagram. Gross is the total energy received by plant. So gross is 20,810. Okay, so that is the energy produced by plant. But 11,977 will be consumed by plant themselves because they are doing respiration. So this energy is used by plant. So it is not passing ahead. So what is the net production? Net production is this 3,366. The one which is going ahead, because out of the left energy after respiration, some of it is also decayed. How much is 5,465? That is decayed now because some plants are dead. They were not eaten by krill. So that energy got wasted because it did not waste. So the net is reaching is 3. Okay. Total minus waste is net. The one which is passed to the next generation, next entity in the chain. So they are calling the blue as net production, but out of that net also the whole net is not going ahead. So this is what is this? They have given this legend. The blue is net, the gray is gross, total is gross. So total energy received by the entity is gross, right? Whatever is received by the entity, like whatever plant received or the krill received or small fish, that is gross. But then one is respiration consumption by everybody and decay. So wo chhod ke jo jata hai, that is the gross for the next entity. Got it? Is it clear? The next diagram 6.8 is also similar. So in both the diagrams, the energy flow is in one direction, right? From sun to consumers. It never goes back to sun. So what if sun's energy is finished? What is that? And we will yes. So but it is still 4 billion years away. So we have to worry. 4 billion is like lot of years away, right? What is how much will we survive? Are you going to live 100 years? Yeah. Assuming you will live 100 years, so in days it will be 36,500 days. So how short, see, when we say 36,500, 365 days in a year is 200. That is 36,500 days. It looks so small, only 36,500 days. But when we say 100 years, it looks big, right? So we are living only in days, forget about billions, so don't need to worry. And if we decide to not marry, then we are liberated anyways. Okay, leave that to your fate. All right. Any questions on this? On the energy flow in the ecosystem? Anybody has any question? So during this energy flow, yes, any question? two things are happening. The energy is getting transformed from one form to the other form. Hence, during transformation, the transformation is not 100%. Some of it is wasted. So these are the laws of thermodynamics. It not only happens in this, in general also. Any energy transformation, these things happen. Right? So let's write down how this energy transformation is taking place. During energy flow, through the ecosystem. System. The laws of thermodynamics are obeyed. What is thermodynamics? Thermo means heat or energy. Dynamics means motion. Because it is flowing from sun to plant to grill, right? So the energy flow is studied under a branch of physics called thermodynamics. So it has two laws. The first law is law of conservation. Yes, conservation of, right? Law of conservation. What does it mean? During flow, so energy cannot be created nor it can be destroyed. Cannot be created nor it can be destroyed. Okay. It can only be transformed from one form to another. Right? So, like I said, whatever sun, right? Only some part was received by plant. Right? It does not mean that the energy from sun got wasted or destroyed. It is not destroyed. It is absorbed by atmosphere. Okay. So what reached plant is only little bit. Okay. And now from solar radiation, it has changed to now chemical energy. Because it is now converted into organic compounds. Organic compounds are hydrocarbons. Hydrocarbons. All the food that we eat, okay, ultimately it will be, we are having what? Calories. So they are basically chemical energy. What is the second law? Right? The transformation. Here we say it can be transformed from one form to another, right? The transformation of energy is ever 100% efficient. Right? Meaning, while transformation of energy from one form to another some part of energy is wasted. Yes. Okay, some part of energy is wasted. So it is not destroyed, it is wasted. It is not fully converted into the next form, wasted. So this is called degraded energy. Degraded or unuseful. Okay, so the wasted energy is not unuseful or degraded energy. Why the energy is degraded? Due to friction, right? So, okay, write down first. So these are the two laws of thermodynamics you will read in higher standards as well. Right? And it is consistent, right? This is what we have observed. Both laws are obeyed, right? Is it understood by everybody? So this is it for unit B. Now we'll move on to unit C, which is sources of energy. If anybody has any questions here? Take this question of energy flow. Can we proceed with that? This is unit C. So, what is the form of energy we are using today? The most used form of energy today? Are we using solar energy? Inside your house, electricity, right? All 24 hours, we cannot survive without electricity, right? So basically, so electricity in today's times, the most useful form of energy is electricity. We all agree? Right. But is energy available to us in the form of electricity? Only during rainy season we get lightning, right? So can we trap that energy and use it? We need electricity. What is the energy available in this form? Water is there, but is electricity available? We have to produce electricity. So we have to convert from the available forms of energy to usable form. And then we can convert electricity to light, mechanical, fan, etc. Right? So if we have electricity, then we can convert it as per the application. Okay. But electricity as it is not directly available to us. Okay. So what are the sources? How do we produce electricity? How do we produce electricity? For that we need sources of it. Right. So first let us understand the characteristics of good energy source. So electricity हम कैसे बनाते हैं? By burning coal, petroleum, right? What else? Natural gas. Again, not only electricity. Electricity maximum we make using by burning coal and petroleum traditionally, right? So basically, to produce electricity, the energy source should be available easily, right? So it should be easily available. Easy availability. What else? The supply should be long lasting, right? So it will be long lasting. Right. What else? It should be safe to use. Yes, safe and convenient to use. Safe as in it should not pollute the environment. Right? What about coal? When we use coal, are we polluting? When we use electricity, are we polluting the environment? Not here, right? When we are using, we are not. But when we are producing, we are. Because how are we producing? How electricity is produced? So basically, it is produced by a device called generator. So generator has a shaft to which some fan is connected, which is called turbine. So we need something to rotate the turbine, and then it will give us electricity. The live, neutral, and argon. These three bars will come out. ठीक है ना? तीन पिन का plug होता है ना, और that is here. Live, neutral, and argon. Okay. So basically, it is the generator which produces electricity, but वो बनाने के लिए somebody has to rotate it. So how it can be rotated? We can build a dam. यहाँ पे हमने पानी रुका दिया. Then we can have a gate, so we can control the gate को ऊपर pull किया, यहाँ से पानी शुरू हो जाएगा. So this energy of water, it will rotate the fan. So we'll store a lot of water so that this keeps on rotating and generator keeps on producing electricity. Okay? So this is ideal electricity. We can rotate this turbine through steam, high pressure steam also. Right? This turbine it could be rotated by steam also. You agree? Pressure cooker. Can you see steam pressure? We used to have steam engine earlier. So how do you produce steam? By burning coal. So you heat water to an extent so that it gets converted into steam. So steam has a lot of energy. that can also be used to rotate. Got it? So that time it will be thermal energy because we want a lot of coal to produce steam. We can also use nuclear energy, right? Because nuclear reaction also produce a lot of heat. We can use that heat to then produce steam by boiling water. And again we rotate turbine. So end of the day, what is the mechanism which we are using to rotate the turbine? That's how the electrical energy gets its name. Whether it is nuclear energy, thermal energy, solar energy. So solar energy में तो generator नहीं होता है. We have a solar panel. So इसमें क्या होता है कि when sunlight falls on the solar panel, right? So there are terminals. Okay. There is a potential difference created between these 2 points. So directly, sunlight is converted into electricity. Here, the mechanical energy is converted into electrical. But here, light is converted into electrical. Okay, so there are different ways in which electricity can be produced. How we are able to rotate the turbine, okay, that becomes the name of the electricity. So nuclear energy में nuclear reaction use किया. Got it? Ideal electricity में hydro energy use किया dam का, right? So we'll study about all that. So ये चीज का जो availability है वो यहाँ पे है. How we are rotating the turbine, that you are right. Got it? Understood? It should be safe and convenient to use. Right? Safe as in non-polluting. जैसे पता चला एनर्जी के चक्कर में घर ही जला दिया, खांस रहे हैं. तो विलेज में क्या करते थे? We use what? Cow dung का जो केक्स है, क्या बोलते हैं उसको? Cow dung केक्स. हाँ? Manure. क्या बोल रहे हैं? It's cow dung cakes only, right? Cake as in. समझ गया. Okay, so it's very polluting, right? Emails, I mean, people who use that, they have a lot of respiratory issues, right? So now everybody has CNG or cooking gas. What else? It should be cheap, right? Economic. Right? Anything else I'm missing on one? Easy to store and transport. Okay, that also. So it should be convenient to store and transport. Right. So all of these are available in electricity if it is available. Okay. So is everybody with me? What are the good characteristics? Characteristics of good energy source. All right. Now let us see what are the types of energy sources. Just reading the book, is there any point missing? Types of energy sources. Are we missing on any point?
No. Classification.
So one is conventional. Another is non-conventional. Conventional कौन सा जो हम अभी तक यूज करते आ रहे हैं, which is fossil fuels. क्या होता है fossil fuels? Basically coal, petroleum. ठीक है, petroleum. Then we have natural gas. So conventional energy sources are fossil fuel based, right? And they are also called as non-renewable. Why? Because once they are finished, it takes millions of years for them to form again. Okay. So what is petroleum? Petroleum is basically crude oil, right? So the crude oil is basically sucked out from the earth crust, right? And then it is processed through what is called as fractional distillation. So multiple products we get when we refine this crude oil. So we get petrol, we get diesel, right? What else we get? We get liquefied petroleum gas, LPG. Right? So LPG is major butane, right? It has a butane gas, then propane and ethane, ethane or propane. In small percentage, ethane and propane. Right. Whereas natural gas is mostly methane. 95% is methane, and rest is ethane and propane. So these are different. So CNG, compressed natural gas. It's not same as LPG. LPG जो लाल cylinder में भर के आता था ना पहले. Now we have pipe gas. So pipe gas is CNG, compressed natural gas. Isn't it? महानगर gas वाला क्या होता है? Is it a natural gas? जो घर में pipe gas आता है वो क्या LPG है? Is it LPG? CNG तो ऑटो रिक्शा वगैरह में डालते हैं, पता नहीं है CNG ऑटो रिक्शा कार या महानगर गैस से CNG होता है, राइट? वही ऑपरेट करता है ना, ऑटो में भी वहां पे तो महानगर का लोगो लगा है. Yes, it is CNG. Natural gas. Okay, so but the problem with this conventional source of energy is it is non-renewable. Plus, it is more polluting. So, no problem is it. So, coal and petroleum is definitely polluting. Okay. Out of this petroleum, LPG is least polluting because it is highly combustible, right? But these products are not fully combustible. So now we have various kind of, you might have heard BS, Bharat Stage 6 and all, right?
Yes, yes.
So, yeah. So these are the kind of engines used.
Yes.
So this is the least polluting. मतलब पूरे का पूरा पेट्रोल डीजल को क्या करेगा? बंद करेगा. So the exhaust will have less pollutants coming out. Okay. So this is decided by the type of thing. All right. So what is the problem with this kind of source? It is non-renewable. And if we continue to use it at the same rate, how long it will last? Another 60 years. Okay. So this supply is going to get over in next 50 to 60 years. So we have to think of some alternative sources of energy. Right? We don't have a choice. We have to look for alternative sources of energy. Because we have to run our trains, cars, automobiles, सब कुछ तो चलाना है ना? कैसे चलेगा? So what are the non-conventional sources of energy? Which is also called as renewable energy. Renewable energy. This is non-renewable, मतलब once finished, gone. Okay. Here we can consume it, yet we can go on creating it. So what is the renewable source of energy? Solar energy. End of the day, it will also end, but in 4 billion years. So it's okay. So for us, it is wind. As long as there is life on this planet, wind will be there. Otherwise, wind energy. What else? Yes. So it's called hydro energy. What is hydro energy? Moving water has kinetic energy. That will be used to produce electricity. Then tidal energy. What is tidal energy? This is also hydro energy only, but so there are certain sites, okay, where you know that high tide and low tide, it happens twice in 24 hours. So whenever there is high tide, so there could be some sites available where that water will fill up the dam, small dams are there, right? But it is very inconvenient to have such sites. It's not available everywhere. It is also very difficult to build such sites, right? So in India, we don't have much tidal energy. Okay, because we have a coastline, but we need a like deep coastline where when high tide comes, there is a natural wall, or you have to build, but then it becomes very difficult to build. So we don't have much of this, but in world like where there are natural sites where they can exploit tidal energy, then they have that source of it. But we don't have much. Next is oceanic waves. Oceans. So this is called wave energy. See, this is only the source. How we extract electrical energy is with the help of devices. We basically build device. What is one such device? Generator, right? So this energy is just the input energy to run that device. The output of that device is electrical. Okay, so for every energy source, we will have a suitable device. Like for solar energy to electrical energy, we will have a panel. Yes, solar panel, right? So just keep that in mind. So for oceanic wave energy, now if you stand at a beach, look at the sea water, there is always a wave, right? So wave is a moving water. So if we can somehow harness that energy and convert that into electricity, so that will become a good source of energy. But right now, it is very cumbersome to basically install a device and maintain it, right? समुद्र के बीच में जाके करना. So it is a very challenging and expensive way of producing energy. So right now we are not producing much energy using these sources. So mostly we are having energy sources by wind, solar, in the renewable space. Otherwise, majority of energy is produced still by coal throughout the world. I'm not saying only in India, right? That's why more energy we are producing, we are polluting the environment that much more. Okay. What else after this? There must be nuclear energy, right? We have biomass. That's the sequence. What is biomass? So this is human, animal, and plant waste. So we eat and then we produce waste, right? So all that is wasted energy if we don't regenerate or recycle it. Okay. So ola kachra, suka kachra, that thing, right? That is a plant waste, right? So human and when the plants are dead, that also, right? So all that human, plant, and animal waste. Human, plant, and animal waste. You must have heard in Haryana or Punjab, Bareilly jala diya ke सामने तो Delhi में pollution हो गया. You must have heard, right? So all those waste can be used to produce electricity through biomass. Okay. So this also. So there are devices available. Okay. Using that, we can create electricity using biomass, right? Geothermal. Now, what is geothermal? So there are certain spots in Earth crust, okay, where steam is trapped inside rocks. So how? Because there are some molten lava, and when the groundwater comes in contact with that molten lava, it gets converted into high pressure steam, and then it is trapped. So wherever that steam is trapped, it is at a very high pressure. Now, if it was not rock, it will erupt outside in form of. So I was just going on with it. So that is geothermal. So the holes are drilled, and with the help of pipe, the steam is taken out, and then it is directed on turbine. Okay. So there are very few spots in US, New Zealand, in India, I think in Madhya Pradesh. That is geothermal. And the last is nuclear energy. We'll talk about it more in the next class. So right now we have just listed more explanation in next class.